Good morning, guys. I want to take a look at a problem like this. Um, Find the values of the other trig functions given that sine of an angle is negative 12 over 13, and the terminal point T is in Q4. So there are two ways to kind of think about this. One of them is based around the material in chapter 5, and another one is based around the material in chapter 6. So I'll go through how to do this based on the material in chapter 5 first. So again, you want to have the material of the blue boxes on page 409 and 415 memorized. So this stuff really hinges off the Pythagorean identities on page 415. So namely, sine squared plus cosine squared equals 1. So we could use that to find cosine with this. We just plug in sine. So negative 12 over 13 squared plus cosine squared equals 1. 144 over 169 plus cosine squared t equals 1. So cosine squared t equals 1 minus 144 over 169. That's 169 over 169 minus 144 over 169. That's 25 over 169. So now we take the square root of that. So we get cosine t equals the square root of 25 over 169. That's 5 over 13. Now, this is where the fact that this is in quadrant 4 is going to come into play. So we have this thing lies somewhere down here, and we're trying to find, this is what t is, trying to find the x and y coordinates at that point. So in quadrant 4, y values are negative. Well, that's great because that agrees with the fact that we were told that sine is negative, and sine is the y value of a location. Cosine in quadrant 4 is positive because x values are positive, and cosine is the x value of your location. So when you take the square root of something, remember you always get two answers. So the fact that this is in quadrant 4 tells us how to adjust our answer here, whether we need to put a negative in front of this 5 over 13 or a positive resulting from the square root. In this case, since the x values in quadrant 4 are positive, we just leave this as 5/13. So that gets us one of our other trig functions. You can find the others like this. So tangent is sine over cosine. Definition of sine over cosine from page 409. The definition of the unit circle definitions view this as y over x, and the definitions, the reciprocal identity, fundamental identity definitions on page 415, it's sine over cosine. So we could literally just plug in the values that we have here. So this is negative 12 over 13 over 5 over 13. This is a really good problem. On questions like this on the test, I'm looking for you to be able to prove to me that you know how to divide fractions without having to rely on your calculator to do them. So this is kind of good practice for that. So that's what the tangent is. Cotangent is just the flip of that. So cotangent is negative 5 over 12. Cosecant is 1 over sine. So that's 1 over negative 12 over 13. Secant is 1 over cosine. So that's going to be 1 over, where was our cosine? 513. So that's 1 over 1 times 13 over 5. 13 over 5. Okay, so there we go. That gets us all these other trig functions. So I'm not sure everyone's foundation with geometry and previous experience with trig is probably varied, but there's a well-known kind of mnemonic called SOHCAHTOA. And this leads us into kind of doing these problems through what you'll encounter in chapter 6, which is triangles. So SOHCAHTOA stands for sine is defined as opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So you could imagine, depending on what quadrant you're told your terminal point lies in, we're going to form one of these 4 types of triangles. Right. So, for example, we were just told that we have something that ends in quadrant 4, so we'd be looking at this guy. So here's our angle, theta or t, whatever you want to call it, and the side of a right triangle not touching the right angle is the hypotenuse. So the angle that is near the origin, depending on the quadrant, that's going to be what t is. So these are all different possible t's for the triangles that you'd create depending on what quadrant you're told your point lies in. So the side of that triangle that we have here that is touching t but not the hypotenuse is the adjacent side. Adjacent means touching. The side that's not touching t and not the neither the adjacent nor the hypotenuse is the opposite side. So what we were told here up above is that sine of our angle is negative 12 over 13. Well, that's the opposite over hypotenuse. It's only the x and y coordinates that could be negative. Hypotenuses are distances and they're basically positive. So this tells us that the negative in this given y value, sines or y values of locations, goes with the opposite, the top of the fraction, and not the bottom. So we could take that information and we could label our triangle. So the opposite side of our triangle here is negative 12, and our hypotenuse is 13. And then we could use the Pythagorean theorem to figure out the third adjacent side here. So we have negative 12 squared plus b squared equals 13 squared. And this is again going to be a positive when we take the square root because this is in quadrant 4, the right-hand side of our coordinate system. So all the x values are going to be positive. And then we could just take these and plug them into the other definitions from the SOHCAHTOA here. So cosine of this angle, again, I'm bouncing between t's and thetas. They're just used to represent an angle. So cosine of this is just going to be adjacent over hypotenuse. Well, adjacent is 5. The hypotenuse is 13. If you note that matches what we got up here. Tangent of our angle here is opposite over adjacent. The opposite is negative 12. The adjacent is 5. What did we get when we did tangent? Negative 5 to 12 over 5. These match. Okay. Anyways, that wraps it up. Hopefully this was helpful. Let me know if you guys have any more questions.